Hey guys, hope you're having a good night. I know there's a football game tonight, so hopefully you got this video done. So anyway, we're going to look at transformations and function notation. So we're going to look at function notation. So far, the function notation that we've used so far have looked like this. F of x, g of x, b of x, and so on. So we've used the letters of our alphabet. So I'm going to change things up a little bit and I'm going to use some Greek letters. So we're going to look at alpha of x, which equals x squared. Okay? Alpha of x. So basically we just labeled this function alpha. Okay? Remember that whatever this letter is the label for the function. So when we're talking about function alpha here, we're talking about x squared, the quadratic function. So we're going to look at describing the effect of each of the following transformations. So we should be familiar with all of these transformations. So I'm going to quickly just go ahead and go through them. Notice that we're in what notation? We're in function notation. So, in function notation, we determine the transformation the same way as if we were actually given the function. Okay? So, negative alpha of x would be the same thing as in this case, that would be the same thing as negative x squared. Okay? So, we all know that this is a reflection, or reflected over x-axis. Okay? And we're in function notation again. So this would be the same thing as that. But we're in function notation here. Okay? So when you see this, we know that this is translated 2 units to the right. Okay, so I'll let you do that one. Now this would be the same thing as if we took the function alpha of x, which is x squared, and added 2 to it. So that would be the same thing as this. So that would be translated 2 units up. Okay? So this would be 2 times the function. So this would actually be the same thing as 2 times x squared. And we know that that would be a vertical stretch. And I'll let you do that one. Now here, notice that the number is on the inside with the x. That would be the same thing as that. So notice it's affecting the x, so we're going to have a horizontal. And it's the opposite of the vertical, so it's going to be a horizontal compression. And I'll let you do that one. Okay, write using function notation a function b, it's beta. Up here, beta represents the Greek lowercase b. So write using function notation a function beta that has a vertical compression and a horizontal translation left. So vertical compression, so we would need a number between 0 and 1. So we'll do, I'm going to do something different. I'm going to go ahead and do 1/7 beta with a little tail. And then we have a translation, horizontal translation left. So x plus 5. So I just did a vertical compression and a horizontal translation left using function notation. So there's my function beta, there's my vertical compression, there's my translation, horizontal translation to the left. Write using function notation a function alpha that has a horizontal compression, a reflection over the x-axis, and a vertical translation up. I will let you do that one. Expect this to be on your video notes quiz. Make sure you have one written down. You might want to check it with me before class. It's up to you. See you guys tomorrow.